Thanks for the introduction. There's a complementary approach called Bayesian A/B testing. And what that does is it is slightly different from the frequentist approach in the sense that it calculates mainly the probability that your group B, let's say you have two groups A and B, your group B has a better response than group A. And that's all it is measuring. And the intuition behind this is, so the intuition behind this is something called Bayes' theorem. And that's, so one way to develop this intuition is, let's say you go to a bike shop, you are trying to buy a bike. And, the shop owner says, okay, this normal looking bike costs $5,000. What would you do? Are you going to just buy it? No, because you have a prior knowledge that on an average, a bike costs $600. So why is that bike $5,000, right? So that's your prior knowledge that you had based on all the experiments of buying bikes in your life that you did. So that's the prior that we can add in the, in the experiment also. That, let's say, marketing is trying a campaign, and it knows historically, what kind of impact it expects to see. So it can have that that as a prior, and basically based on that, it can sort of restrict how, what kind of lift is allowed to see in that particular campaign, and that sort of helps rule out all the possibilities that it can happen during the experiment. So that's the rough intuition of what Bayes' theorem is. So in this case, for the Bayes' theorem, what we're doing is we are not defining any lift a priori. We are simply running the experiment based on some prior belief. And as I go through the experiment, my prior is getting updated based on the experiment result continuously. And I'm computing the probability that B is greater than A. And as soon as I hit a certain threshold that is again defined by business, I can say, okay, here is what I'm seeing, and then I can go find out who the users are who are most responding to this, experiment, and then maybe channel the rest of my marketing campaign to those types of users. So it sort of have a continuous pattern to that.
So basically, it's like the number of miracles required to prove God. That's what believer and an atheist.
Yes. I should have said this and saved 90 minutes. No, but that's a good point. These, I think I cannot do justice what a conjugate prior is in this lecture, but I just put it out there so that you can do further reading if interested later on, just to give you pointers of what it takes to build a Bayesian A/B testing. So there is something called conjugate prior that we use. So you can just look at it later on, but I just want to walk you through it. So this is the A/B testing frequentist approach. If you just run this end to end, like the previous speaker was showing how the notebook is run, you can actually do an end-to-end A/B testing basically. That's what this is, and this probably cover 80% of the industry cases that we currently solve, and you can play around with required sample size and required lift and see how the sample size changes as you increase or decrease the lift, or if I change the type 1 and the type 2 error, and how it changes, so that to give you a feeling for how these things are changing. And this is also a similar notebook, but for Bayesian A/B testing. So this is slightly bit involved, but basically again this is going through a test case where I took this example where you have an e-commerce company, X people purchased, Y people did not purchase, you have the purchase rate, And imagine that you are actually doing this experiment, but you are doing this continuously, in continuous fashion. So in that case, you can basically, go through this notebook, and the result that you are basically looking for is how much B is better, and it gives you sort of a probability distribution. So this is your probability distribution, and this shows that the peak is around 40% lift between treatment and control with a certain probability. So that's sort of the end result that you get from Bayesian perspective. And the business reason to do that is you can basically do your A/B testing in a continuous fashion and stop early.
How early?
That will depend on how much lift is okay with you.
In your example, you said you collect the data for run it for a week.
Right.
You get that 7 days of it.
Right.
You do Bayesian.
Right. So that's what I'm saying. So it will vary from experiment to experiment, but on an average, you can, stop, let's say, 50% early. So let's say an experiment is supposed to run for 3 weeks before you get enough sample size. And this is especially true for marketing, because marketing tend to have very small lift, because small lift matters to them. Like they are probably trying to measure 0.2% lift. So 0.2% lift requires 10 million users, roughly. So in order to get 10 million users, you need to maybe wait for 4 weeks in a frequentist approach, and then decide, okay, now which particular user I should spend my next million on, right? So that's a big, business expenses. On the Bayesian side, what you can do is you run it for, let's say, 1.5 weeks. You see where the lift is going, how much it is performing for what type of users, and then decide, okay, I stop at $400,000, and my next 400,000 will go to these users, and then so on and so forth. Yeah. Yeah, so that's a great question. So Bayesian A/B testing does not promise you anything about the power, because that's not part of the equation. Right. It's basically a risk-based measurement. Sometimes we are actually okay with it. It's basically, if I can, in this continuous fashion, if I can home in on whatever the type of users I want to capture, sometimes I'm okay to not attain the sufficient number of powers. So that's more like a business drivers. Yes, for pharma you are supposed to not do that. However, there is a better version of Bayesian A/B testing. So Bayesian A/B testing had its the shortcomings that you just mentioned. The sequential A/B testing kind of take the best of both worlds. So it has this frequentist A/B testing of required type 1, type 2 error, and it also has the Bayesian A/B testing of the continuity of the experiment, and kind of combine the two. And I think the paper is out in 2016. They solved part of the problem, but not everything. But yeah, it's very much cutting edge stuff. But it addresses some of the problem that you mentioned. It's a paper by Optimizely. You can Google, I forgot the name of the author, but basically if you Google sequential A/B testing Optimizely, I think you will get one hit. Right. So for startups, this is where things get less sciencey and more anecdotal, right? So, basically, if you don't have enough users, you can, you probably have some users, and you can form some opinion based on that. There is one technique called causality analysis, right? So I did not cover all these things. Although we did discuss the collision effect some extent. So causality is essentially if you don't have enough users and you are basically trying to predict a trend, it does have less power and more noisy outcome, but you can draw some conclusion based on that.